Welcome to Go Lesson 13, Anonymous Functions and Closures. Anonymous functions are functions without a name. They are powerful building blocks. Closures capture variables from their surrounding scope, enabling stateful functions. You will learn function literals, immediately invoked functions, and factory patterns. Let's start with anonymous function basics. An anonymous function has no name. You assign it to a variable. The variable then holds the function, and can be called like any function. Here greet holds an anonymous function that takes a name parameter. We call it just like a named function, using parentheses. Anonymous functions can return values too. The add function takes two integers and returns their sum. Functions are first-class citizens in Go. You can pass them as arguments. This apply function takes a slice and a function to transform each element. We pass an anonymous function that doubles each number. This is a powerful pattern for custom transformations. Each element in the slice was transformed by our anonymous function. Now let's explore immediately invoked function expressions. An IIFE is defined and called in the same statement. The parentheses at the end immediately execute the function. This function runs once, right when it's defined. No variable needed. You can pass arguments to an IIFE just like any function call. The arguments go in the parentheses at the end. IIFEs can return values which you can capture in a variable. This is useful for complex initialization that needs isolation. IIFEs are perfect for initializing complex data structures. Here we create a config map inside an IIFE and return it. IIFEs provide scope isolation. Variables inside don't leak out. Notice the X inside the IIFE is different from the outer X. The outer X remains unchanged because the inner X was local to the IIFE. Now let's dive into closures. A closure captures variables from its surrounding scope. The function remembers those variables even after the outer scope ends. This function closes over the message variable. It can access and print message even though message is defined outside. Closures see changes to captured variables. When we change message, the closure reflects that change. The classic closure example is a counter. The closure captures count and increments it on each call. Each call returns a new value. The state persists between calls. Each closure gets its own copy of captured variables. Make counter returns a new closure each time, with its own count. Counter 1 and counter 2 are independent. They don't share state. This independence is what makes closures so powerful for encapsulation. Let's explore the factory pattern with closures. A factory function creates and returns other functions. Each returned function captures different values. The multiplier factory captures a factor. It returns a function that multiplies its input by that factor. Similarly, the adder factory creates functions that add a fixed amount. Each created function remembers its own amount. Here is a practical example: a logger factory. Each logger remembers its prefix and uses it in every message. Let's create specialized functions from our factories. Double, triple, and times 10 are all from the same factory. The adder factory works the same way. Add 5 and add 100 each. Remember their own amount. Each logger has its own prefix baked in. This pattern is common for creating pre-configured utilities. You can chain factory-created functions for complex transformations. The factory pattern with closures is powerful for creating specialized functions. Let's recap anonymous functions and closures. Anonymous functions have no name. Assign them to variables or pass as arguments. IIFEs run immediately. Closures capture outer variables. Factories create specialized functions. Thanks for watching. In the next lesson, we explore pointers in Go. Like and subscribe to continue your Go journey.